Hello and welcome to Database Management Systems. I'm Jovita Christie, and this video is in continuation of the previous video where I explained subqueries. So I'm going to go a little bit deeper into subqueries in this video, and you'll learn about 5 more queries to demonstrate how subqueries are used in SQL. The database being used here has been created in 2 of my previous videos. And if you would like to create that, those videos are available in the description box. There's a link. And let's start. There are 4 tables once again. The 4 tables are employees, departments, works on, and projects. And we are going to apply all the queries on those 4 tables or some of those 4 tables. So let's see query number 4. You can see the question on top of your screen. It says find the names of all departments not currently assigned a project. So departments that are not currently assigned a project. Now in this case, we need to find names of departments, which we can get only from the departments table here. So we can only get this from the departments table, the name, and whether or not they are assigned a project. That information is available from the projects table. So from the projects table, we have a column called dept code. So whatever code is present in the projects table, that department has been given a project. But if there is a code present here but not present here, then that department has not been given a project. So we can verify this before we begin. I'm going to select all the codes available in departments, which are these 4. And I'm also going to select the dept code available from the projects table. And they are here. So you can see that there is HDWRE, which is not present here, which means this is the department that does not have any project assigned, and that department's name we can get from the departments table. The name is hardware. So this should be our result, hardware. Now this query can be done using a left outer join, as I did it in one of my previous videos. But this can also be done using a subquery. And since we are learning subqueries, that's how I'm going to do it. So first of all, the thing that needs to be displayed is the name of a department. So select name from departments, where, and the condition that I'm going to apply here, in the previous video, in the last query, I applied a condition where I used the keyword in. In this case, I'm going to use the keyword not in and write another query where I will select all the dept codes from the projects table, and it's as simple as that. So what I basically did is to select the name from departments with the condition that the code of that department should not be appearing in the projects table. So it's very simple. In the projects table, I have 3 dept codes appearing, and HDWRE does not appear, and that's why it gets displayed here like this. So this is a fairly simple query, and it demonstrates the use of not in over here. Notice that you cannot use not equal to instead of not in, because the query inside is going to return multiple values. If your subquery is returning only one value and you're sure of it, like we did in the first query in the last video, if you're sure that it's going to return just one value, then you can use equal to or not equal to. But when the subquery returns several values, you have to use either in or not in, because in that case you're dealing with a list instead of just one value. Let's proceed to the next question. This is find the first and last names of employees who make more than the average salary of the people in accounting department. Now this is the type of question that is very easily solved using a subquery, because even when you're thinking about it, it's much easier to solve using a subquery. So it says find the first and last names of all employees who make more than the average salary of the people in accounting department. So by reading the first part of the question, I know that I need to select the first name and the last name from the employees table. Now, another thing is also that the salary of these employees, which I am selecting, must be more than the average salary of people in accounting department. Now, to find out this type of a thing, I need to put a condition on the salary column. So where the salary must be greater than, and now what I need to do is find the average salary of the people in accounting department. In order to do that, I have to write another query where I'm going to do select average salary from employees, and to do this average salary, I'm going to do a group by, because I want it department wise. So group by debt code, and then I'm going to use the keyword having and put a condition on debt code. And now what I want is the debt code of accounting department, which I can get from the departments table by writing another subquery that selects the code from departments table where the name is equal to accounting. And then we can close this. Now notice that I need to close this bracket twice, because this is not not a question where I've written two subqueries. I've actually written a subquery inside a subquery, if you notice, because this is the outermost query. This query is the inner query, but then inside this query also there's another query, which is this one. And so I need to close the bracket twice and put a semicolon and hit enter. And this is what I get. Now to verify the answer, of course, I would have to run these queries separately. So if I run the accounting query separately by removing the brackets, then I will get ACCNT. So ACCNT is the code of accounting department. And so this whole query will get replaced with just ACCNT. And we are sure that accounting will have only one code, and that's why we are using equal to here. Now, ACCNT is only one thing. Now, here in this query, we are trying to get the average salary. So let's run that query. This is the query. And here I need to remove the bracket. Let me take it up. Yes. So now this is the query. Here the depth code is equal to ACCNT. And how do we know that? Because we found the result of this query, which is the innermost query right here. From here, we came to know that the depth code is ACCNT. Now let's run it, and we get 40,000. So 40,000 is actually the average salary of people in the accounting department. If you want to verify it, you can take a look at what is there in employees. So actually we have only one employee in accounting department, and his salary is 40,000, which means the average is 40,000 itself. So when we wrote our previous subquery, this subquery, query inside a query, this one resulted in these employee names. So it is Al, be the leader, Harry Hardware, Susie Software, and Hardly Aware. And you can check that their salaries are greater than 40,000, as you can see. Number 4, 5, 6 are also, number 3 and 4 are having greater than 40,000. 6 is also having greater than 40,000. And that is what we got as a result of subquery. So this is how subqueries work in practice. Let's do one more subquery. This one says, find the descriptions of all projects that require more than 70% of an employee's time. So in this case, we will be using two tables, and those are, let me clear the screen first. We will be using two tables, the projects table, because I want the description of the projects as per the question. And we will also be using another table called the works on table, since I need to make sure the time is 70% or more than 70%. This is a fairly simple query. It does not use anything fancy. We are going to select the descriptions from the projects table and put a condition that the project ID, because the only thing common between projects and works on is the project ID. So I have to put the condition on the project ID. That project ID must be in whatever we select here. From here, we are going to select, from works on, we are going to select those project IDs where the assigned time is greater than 0.7, and close the bracket and run it. And there's only one such project, which is Robotic Spouse. We can verify that by checking the projects table. In projects table, there are only two projects with time more than 0.7, and both are actually having the same code, which is Robo SPSE. And if we select the project ID and the description from the projects table, we will be able to get, just a second. We will be able to get these, we will be able to know that Robo SPSE is the code of Robotic Spouse, is the project ID of Robotic Spouse. So this is a very simple query. Let's see another one, next one. Now the next query says, let's clear the screen. Next query says, find the first and last names of all employees who are paid more than someone in the accounting department. So it is not saying that they are, we are not asking you to find out someone who's paid more than the average salary of accounting department. This is a slightly different question. It says that more than someone in accounting department. So if there are 10 people in accounting department and the person with the highest salary is 70,000 and the person with the lowest salary is 25,000, then we are actually trying to compare everything with 25,000, because if your salary is greater than anybody's salary from accounting department, then your name will be appearing here. So let's do this query. The reason why this question is there is so that you understand how you can use the keyword called any in the terms of subqueries. So what we need to display here are the first and last names from employees table, where what we have to compare is the salary greater than, but after greater than, I'm going to add a keyword called any, because greater than, equal to, all these things can be used only when the inner query is going to result in giving us only one value. It's going to result in giving one value, but we want the salaries of people in accounting department. And people in accounting department, we do not know how many there are. So we are using a keyword called any, because the question itself says that they should be paid more than someone in accounting department. Now let's hit enter and put the next query, where we will select the salaries of people from employees from the accounting department, but I do not know the code of accounting department. So I need to write another subquery to say that the depth code must be equal to select code from departments where the name is equal to accounting. This will give me the code of accounting, which is CE-IT, and then that code will be supplied here. And because of that, I will get salaries of people in accounting department. And then I will get names of people who are having salary more than anybody in accounting department. And so let's run it. I forgot to put one of the parentheses here, so I'll add it because it's a subquery inside a subquery. So these are the names. So how exactly does it run? Now I'm not going to run this query, but I'm going to run this in a query. So the first thing is the code of accounting department, which will be CE-IT without running the query. So the inner query, which is selecting the salary of people in accounting department, will be equal to this CE-IT, which gives us 40,000 because there's only one person in accounting department. So whatever you're getting here are people whose salaries are more than 40,000. And if you have some other name, for example, there are people also in consulting department and we have more people there, so more than one. So I could change it and write consulting department. Now if you check in your table, consulting department has 2 people. The lowest of these salaries is 30,000. So even though there's 30 and 62 available, everybody's salary is actually compared with 30. And whichever salary is greater than 30 will be displayed here. So these 3 people are displayed here. Even Susie Software is displayed here because her salary is greater than Abe Advice. And also Harry Hardly Aware is displayed. So that's how this query works. And let's clear the screen now. You can of course pause and try it out on your own and then come back here. Now, the next and the last question that I'm going to do is this one. Find the minimum salary of the employees who are paid more than everyone in the accounting department. So this is slightly different. It says not more than anyone. The previous query said more than anyone, but this one says more than everyone in the accounting department. So this is a slightly different question. It can be solved in this manner. First of all, we need the minimum salary. So we are just going to select the minimum salary from employees and then compare this salary, and it should be greater than all the salaries that we receive from accounting department. So once again, we are going to select the salary from employees where the depth code is the code of accounting. To get the code of accounting, we are going to write the query like this. Select code from departments where the name of the department is equal to accounting, close bracket twice, and we are getting 50,000. How did we come upon that answer? We can see from the employees table. Employees table contains only one person in accounting, so the salary getting selected in this second query is actually 40,000. So after 40,000, the minimum salary greater than 40,000 is 50,000. So that's what we are getting here as a result. And you could indeed modify this query to do, instead of accounting department, to use consulting department. And then you'll end up getting 65,000. There are 2 people in consulting department, 60,000 and 30,000, but the highest of these is 60. So the next salary that is minimum after 60 is 65,000. So that's why we are getting here as a result 65,000. So this is the difference between the keywords any and all. Any is matching, is trying to put the condition on anything that's available, but all will make sure that it satisfies all the conditions. So that's it for the subqueries in SQL and for this video, and I'll see you in the next one. Thank you for watching.